The support tower is assembled by joining three parts together. Now, these crumpled areas are not at the seams, so there are some unusual aspects. Hello everyone, this is Error. A wind turbine in Hwasun, South Jeolla province, collapsed completely. This caused a major issue. Local residents are very anxious. This happened the day before yesterday. At around 2:50 a.m., the day before yesterday, multiple wind turbines in Domyeon, Hwasun County, toppled from a height of approximately 30 meters. The local residents, mistaking the incident for a significant earthquake, are deeply worried. Thankfully, there were no injuries, but the companies involved are planning to investigate whether this issue might persist. Let's quickly go over the technical problems. Take a look at this image. You can see it's completely bent over. Other turbines are fine, but this one looks like a crumpled straw. It's completely folded and crushed. People who have seen wind turbines know they look huge even from afar. Up close, they are absolutely massive. The bent part is 30 meters high. That's like a 10-story building. Taking into account that the collapse happened from such a significant height, it is evident that the rotor and wind blades, which are notably heavy, caused substantial vibrations upon making contact with the ground. Generally, the wind turbine structure consists of the rotor blades and the support tower that holds everything in place. The lower 30 meters of the support tower, which is assembled in three distinct sections, is precisely where the bending occurred. These towers are too long to be made in one piece at the factory. So these are divided into roughly three sections before being assembled. Interestingly, the area that bent is not located at a seam, which is quite unusual. Support towers are usually made by rolling thick steel plates into a circular shape like this. The plates are gradually rolled and carefully aligned to create the desired circular shape. So when they gradually shape it into a cone, they reduce the curvature on the side with the smaller diameter to make it smaller. Mechanical engineering and material science students often study this in courses like mechanics of materials. This is known as buckling. In Korean, this is referred to as jwagul. The bending in the middle of the column can be explained as a buckling phenomenon. Simply put, that's what it is. When we discuss general buckling, it refers to the overall bending that occurs under pressure. If a specific part of the support tower is slightly indented, it will buckle and crumple around that point due to the stress concentration. This means stress concentrates in that area. It causes a sudden bend under pressure. This indicates there might have been a design defect from the beginning or an issue at a specific weld. The constant stress on this section can lead to buckling, also known as jwagul, pronounced druggle. Alternatively, there could be corrosion, but it has only been in operation for about 2 years. Could it have corroded already? Or maybe the material used wasn't thick enough, which is currently being investigated. There is a possibility that the steel plate used here wasn't sufficiently thick. Concerns have also been raised about the wall thickness being inadequate. In this scenario, what you are observing involves the rolled steel plates, and if either the thickness of these plates or the bending sections were not meticulously calculated to withstand the stress, it could result in localized buckling rather than the more common general buckling. This could in turn lead to significant structural issues. But this wind farm was built in 2020, which was during the COVID-19 pandemic. There was a supply shortage of steel plates, so there's speculation that maybe the steel plates used were not up to standard. I found that reporter Lee Young-jun from Newses explained it well. He took close-up photos. You can see the folding. The size is huge. Compared to a person, it's enormous. The local residents must have been very shocked. The height is 127 meters. He explained that the design follows specific standards, and each wind turbine's diameter is determined by these set criteria. The turbine was 4.7 megawatts. Its diameter should be at least 5,000 millimeters. The steel thickness must be at least 30 millimeters. These factors are being investigated. As mentioned earlier, thick steel plates were used in the design. However, the turbine was built during a time of supply issues. We need to check if they were used correctly, or if standards were not met. There might be unique geographical factors in Hwasun's mountains. Factors such as wind patterns or gusts might not have been adequately considered during the design process. Even though the structure withstood typhoons, it is possible that the repeated stress from these events could eventually lead to buckling. This suggests that over time the structure could weaken, much like how materials accumulate fatigue. If a specific part of the material keeps accumulating stress, it could eventually buckle even under a weaker wind. This is a scenario we need to consider. Back in 2016, a similar incident occurred in Taebaek, Gangwon province. However, such incidents are quite rare globally. However, the incident in Taebaek was due to a failure at a specific joint, indicating a different problem than what occurred in the recent case. In this recent case, the support tower buckled in the middle, suggesting that the steel plates might not have been properly installed. Given that such occurrences are rare globally and Siemens manufactures this tower, it's crucial for manufacturers and designers to collaborate closely. They need to thoroughly investigate to ensure that the materials used comply with the necessary standards. There has been notable opposition from local residents to renewable energy projects. Incidents like this make it even more difficult, and South Korea is already behind in developing renewable energy. Nevertheless, if these safety concerns aren't thoroughly addressed in advance, they might develop into more serious problems. We earnestly hope the cause of the accident will be identified with accuracy and precision. On a lighter note, high-quality hoodies are available for group orders at the Andy Engineering store. We also share short news summaries and videos on Instagram, so stay updated with our latest news. This has been Error.